This is SpaceTime Series 25, Episode 122, for broadcast on the 14th of November 2022. Coming up on SpaceTime, mysterious cosmic radiation storms targeting the Earth, another delay in the Artemis 1 moon mission, and 23 tons of Chinese space junk comes crashing back to Earth. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Mystery continues to surround a series of strange cosmic radiation storms which have been pummeling the Earth at regular intervals for thousands of years. The huge bursts of cosmic radiation are known as Miyake events, but their origins remain shrouded in mystery. Now, a team of scientists have shed some new light on these unpredictable and potentially devastating astrophysical events, finding their signatures in tree rings. The study's lead author, Benjamin Pope from the University of Queensland, says these strange events have occurred approximately once every 1,000 years, but what's causing them remains unclear. Pope and colleagues applied cutting-edge statistics to data from millennia-old trees to find out more about these radiation storms. He says the leading hypothesis is that they're huge solar storms, blasts of energy known as superflares, erupting out from the sun. But the new data, reported in the Journal of the Proceedings of the Royal Society A, doesn't support this hypothesis. Pope says science needs to know more, because if one of these massive blasts just happened to occur today, it would destroy technology as we know it. It would wipe out satellites, fry internet cables, and severely disrupt long-distance power lines and transformers. The effect on global infrastructure would be unimaginable. So, to better understand the frequency and characteristics of Miyake events, Pope and colleagues decided to investigate the tree ring history using software they developed themselves. You see, when radiation strikes the atmosphere, it produces radioactive carbon-14, which then filters through the air, through oceans, plants, and animals, and becomes part of an annual record of radiation preserved in tree rings. And because you can count a tree's rings to identify its age, you can also observe historical cosmic events going back thousands of years. So, the authors modelled the entire global carbon cycle to reconstruct the process over a 10,000-year period, that's going all the way back to the Ice Age, in order to gain insight into the scale and nature of Miyake events. Pope and colleagues found that these events do not correlate with sunspot activity, and some actually lasted for 1 or 2 years. He says rather than a single instantaneous explosion or flare, what scientists are seeing may look more like a kind of astrophysical storm or outburst. Pope says the very fact that scientists don't exactly know what Miyake events are or how to predict them is disturbing. He says based on the available data, there's roughly a 1% chance of seeing another one within the next decade. Pope says he's concerned we don't know how to predict these events or have a real understanding of the sort of harms they could cause.
6 times in the last 10,000 years, tree rings reveal a huge burst of radiation striking the Earth, and we don't know the origin of it. And so my research is into trying to understand what these are and how we can predict them, mitigate any harms that they might cause, and use these to better understand cosmos and archaeology.
So what are our best hypotheses regarding what's caused this sudden burst of cosmic radiation?
So people have proposed that these bursts of radiation be caused by supernovae or gamma ray bursts, or maybe by magnetar bursts, that is, explosions on the surfaces of neutron stars. Neither of those hypotheses really has a lot of support. I mean, people have proposed Earth being struck by a comet enriched in carbon-14. Again, not very likely. Most scientists think that these Miyake events are caused by giant solar, we call them superflares, much bigger than any kind of solar flare that's been ever observed on the sun in the technological era, but as large as has been observed on different stars using space telescopes.
So we've had some big solar flares that have occurred close to the technological era. I'm talking about over 100 years ago with the Carrington event. Is that the sort of thing, or does that qualify?
Yeah, so the Carrington event occurred in 1859. It was really serious, caused aurorae all over the world, but it also blew out telegraph wires and caused huge deviations in the Earth's magnetic field. If one of these occurred today, it could be very disastrous for power grids and for the internet and for satellites. But it produced almost no recorded record of extra radiation striking the Earth. In fact, the best estimates are that the original Miyake event to be discovered, the one in 774 AD, would have been at least 80 times bigger than the Carrington event. And so this would be sort of unimaginably larger than the biggest solar flares that have ever been recorded, which are in fact enormously larger than the biggest ones we've observed in recent decades.
How do you even know they happened?
It all comes down to tree rings, right? And so all the trees in a particular region have pretty similar growth patterns. A good year for an oak in one part of Europe is usually a good year for an oak in another part of Europe. And so trees have these light and dark, thick and thin patterns of rings, right, that are laid down annually in their growth season. Now, one tree in the same species and region has pretty similar pattern to another. So what you can do is this. You can daisy chain. Suppose you cut down a 300-year-old tree today. You probably shouldn't, probably quite valuable.
I was about to say that.
But suppose you did, right? Then it would have 300 tree rings, right? You can count all the way back to the year in which the tree was seeded. Now, suppose you found in an old building a beam of wood. This is quite often how it happens. Or you found in a bog a preserved tree that had fallen in. That's another of the ways that you get these ancient samples. Well, you can count its tree rings, and then you find that the last 100 years of its life is a very similar pattern to the first 100 years of life of this modern tree. And so now you know that those were the same years. And so you can now go from 300 years going back to maybe 500 years going back. And in fact, what you do is you daisy chain these all the way back to the end of the last ice age, when the slate really gets wiped clean. And there's these huge libraries at some universities like Cornell where they have enormous collections of tree rings. You have a whole science of what's called dendrochronology, that is getting absolute dating of archaeological tree ring samples. And people are really good at this. People have got libraries of different species and regions to match patterns. They call it wiggle matching in order to be able to accurately register one against another. So you can request a sample of trees from, 7,000 years ago, and they exist. And so this is really good for a lot of reasons. But one of the things that's particularly exciting is it can be used as a record of radiation striking the Earth. So these tree rings provide an archive of the radiation striking the Earth. And the reason is this, because tree rings incorporate carbon, as do all organisms, and a minute fraction of carbon in the sort of the biosphere is radioactive carbon-14 as opposed to stable carbon-12 isotope. And so carbon-14 is produced when radiation strikes the atmosphere and causes nuclear reactions with nitrogen, the bulk component of the atmosphere. And it produces carbon-14, which in very small quantities filters through the atmosphere and oceans, plants and animals, you and me, through the whole carbon cycle. And it gets locked, among other things, in tree rings. And the ratio of carbon-14 to carbon-12 in the year of the tree ring being laid down is therefore preserved. Some of it radioactively decays, but you know the exact year of that tree ring. And so what's really cool is you can therefore infer production rate of carbon-14 from this radiocarbon as a function of time that tree rings tell you. And it tells you all sorts of things. You can see the 11-year solar cycle in there. The reason is that when the sun has lots of sunspot activity, it's got a strong magnetic field, and the strong magnetic field actually shields the Earth from cosmic rays. These cosmic rays produce carbon-14. So strong sun means low carbon-14 production, whereas a weak solar magnetic field means more. So sometimes you actually also see what's called the grand solar minima, like the Maunder minimum or the Dalton minimum that have occurred historically recently, where you see a rise in radiocarbon production over some years because the solar magnetic field is so weak. You also see the same thing with the Earth's magnetic field. When the Earth tries to go through one of these geomagnetic reversals, you can actually see that in tree rings. You see a rise in radiocarbon as the Earth's magnetic field gets weaker. So far so good. You see sometimes dips where there's big volcanic eruptions, where it dumps a lot of old dead carbon into the atmosphere that dilutes carbon-14. But you also see these Miyake events, which are sudden single-year rises of huge amounts of radiocarbon, several ordinary years' worth of production being delivered all at once. And we don't know what they are.
It's a mystery.
Yeah, no, it's really, it's not a complete mystery. People have done the numbers and it sort of plausibly works out for being caused by the largest kinds of super flares that we sometimes see on other stars. But we don't have a lot of direct evidence yet. So that's where I come in. I'm not an archaeologist. I like archaeology. I think it's cool, but I'm not out there digging up King Tut. I'm an astronomer, and I'm really interested in stellar flares. I've recently been working on flares from M-dwarf stars, red dwarfs, using the test space telescope. And so I was interested in this unique record of long-term solar activity, and in the problem that there was a lot of plausible evidence that these Nyaku events in radiocarbon record and tree rings, extreme solar events, but there wasn't a lot of conclusive evidence, in my view, and in the view of a lot of people. And what I had to do was to set out to prove, using the largest ever statistical analysis of these data, that this was the case. And so what we did with our team, we had these amazing undergrads, so brilliant. Qingyuan Zhang was the first author of the paper. He worked with Utkarsh Sharma and Jordan Dennis, 3 undergrads at UQ in maths and physics. We built open source software to model this whole carbon cycle, how the radiocarbon filters in through atmosphere and oceans, plants and animals, sediment and bogs, and into tree rings, to really accurately model these data, and then tie these to modern statistical tools to try and accurately infer what the sort of the history of these was. You know, how big were these events? How long did they take? What was their relationship to the solar cycle? And what I hope to be able to statistically show is that these occurred only when the sun was at maximum activity, and that they were very short and sharp, and that this would prove that they're super flares. Now, what we actually showed is not really quite that. We didn't rule anything out, but actually a couple of the events seemed to take a couple of years, or at least the tree ring data seemed to show a slower response than can really be accounted for with our current knowledge of how trees grow and how the carbon cycle works. But actually it could be some weird weather, climate sort of stuff going on, or it could be sort of stored sugars in the tree rings, or systematic uncertainties in how the tree rings are cut up. So there's a big uncertainty there. They also didn't occur at the peak of the solar cycle. One occurred at the peak, one occurred at minimum, one occurred halfway between, which is again not to say that there's definitely not.
That just totally destroy that hypothesis then when they're occurring all over the place like that?
Yeah, it's a bit concerning. It's small number statistics, right? So you get big solar flares even at solar minimum. So solar flares are about 4 times more likely at maximum than minimum, which is a pretty good ratio, but it's not an amazing ratio. And so, it's plausible that you'd get one at minimum, but, it would have been really nice if they'd all lined up at maximum. We could just prove it. The duration thing, it could be something to do with the weather, spreading out this signal over a couple of years, or with trees, something to do with their growth, spreading out the signal into the tree rings over a couple of years. Or it could be because the event itself is intrinsically long. Maybe it's a storm of many solar flares, or maybe it's something like these grand solar minima but shorter, or something like that. The thing that will really clinch that is complementary evidence from ice cores, where you also get, at the same time as carbon-14 is produced, you get beryllium and chlorine, beryllium-10 and chlorine-36 isotopes, and they get rained out pretty promptly. They don't go into the whole carbon cycle thing, and you can pick them up in Antarctic and Greenland ice. And so there's a team at the Australian Nuclear Science and Technology Organisation, ANSTO, in Lucas Heights, south of Sydney, who've been trying to do exactly that, of get really accurate measurements from Antarctic ice cores. And I'm really keen to see what the results are.
And another complementary diagnosis would come from solidified magma.
Well, here's the issue, right, is that these events, you need to be able to resolve things annually. And so there's all sorts of geological things that could record heaven knows what. But unless it records an exactly annual signal, or shorter than annual, or something where you get really good timestamp, it's no good to it. So tree rings are good because they're annual growth season. Ice cores are laid down in the annual seasonal cycle of Antarctica or Greenland. But magma, we don't know for the single year when it was laid down, typically, except for very recent eruptions. Ancient eruptions we might know for the century or to the decade or whatever, but not for the single year. Now, this is what makes it quite a tough problem. There's only a few sorts of data which give you the kind of time accuracy to be able to really see the duration and timing of these events.
Did the Carrington event show up at all in tree rings?
No, No signal at all. That's something that's always disturbed me. I mean, the estimates say that these things were 100 times bigger than Carrington, like 80 times bigger than Carrington. But it's weird that we have no direct evidence that solar particles produce these events. Now, I'm not getting on some high horse saying, listen to me, Galileo was wrong. You know what I mean. There's a lot of. I've got some crazy emails over the last few weeks. Some very interesting proposals. I do think that our existing model is showing some wear and tear, and I really think we need more data and more computer models, particularly of how the weather works, and also data on how these trees and their growing seasons work really, really accurately at the month level. I think this is a very interesting open question. It's really important that we resolve it, right? Because it's a magnetar burst that could be harmful. It's supernova, well, there's probably nothing we can do about it. The solar flare, we can predict and mitigate the effects if we know what to look for in advance. And, these kind of events happening once every 1,000 years seems like a pretty low risk, and it's certainly not something that I lie awake at night thinking about, and I work on this sort of stuff. But as a society, it's something that we should have a contingency plan for, because once in 1,000 years is a 1% chance per decade. And so I think we do need plans for, what if something could cause billions of dollars damage at a 1% probability per decade? That's actually pretty concerning. And so what we need is more data and better models in order to actually say, are these Miyake events super flares or what are they?
So we see super flares from M dwarfs, from red dwarfs. That's pretty common, but that's understandable because of the internal structure of those small stars. For a star like the sun,
it's very, very active,
with radiative and convective layers as well, then it's a very different sort of structure. But there have been occasions, I understand, that we have seen G-type stars that have sparked super flares.
Yeah, so this is sort of a very active topic of research. There's sort of a few caveats to that. The sun is a middle-aged star, and so when stars are born, they're typically rapidly rotating. So the rotation drives the magnetic dynamo, and the magnetic dynamo drives like flares, sunspots, but also magnetizes the wind, which allows it to carry away this rotational energy. And so sun-like stars are born fast rotated with lots of magnetic activity, and then they slow down and sort of turn off. And so this sort of period where the dynamo undergoes actually a phase transition to a different kind of dynamo that's much weaker occurs in middle age. And the sun is actually one of the only stars we know which is actively in this process of changeover. And so the sun's dynamo is atypical of typical stars. Most stars we can find that are solar-like are either a little bit older and very magnetically inactive, or a bit younger and much more magnetically active. And so if there's G-dwarfs with super flares, that's one thing, but they're typically young. And so other stars are not actually a great indicator of the sun, really, and what its potential sort of dynamo activity could be. It's one of these funny things where Kepler stared thousands of stars for 3 years, right? Thousands of G-stars for 3 years. Whereas the radiocarbon time series is one G-star for 10,000 years. So actually they've got about the same number of star years of data, right, on the sun and every other star. And so every other G-dwarf that we've been able to observe, that is. And so, this is quite a unique record that really powerfully constrains solar physics, if we can interpret it correctly.
Rather than something coming from our sun, these things are triggered by cosmic rays. It doesn't have to be cosmic rays from the sun. It could be deep space cosmic rays as well.
Yeah. I love the idea that it's a magnetar burst. It'd be really fun. There are no magnetars that are known that are close enough to really have this effect on us. But it's like, it's a pretty cool paper proposing this.
And we saw nothing like this when supernova 1987A happened. So because although we saw photons from that thing, it's actually the neutrinos which hit us first, of course, because these things are actually neutrino explosions, not photon explosions. There was nothing untoward there. So
I've checked really hard on supernovae with my colleague who was the lead archaeologist on this paper, Mike D, who's a Kiwi guy in Groningen. They've done a lot of work on this, and we've done a bit of work with them where we looked at all the known historical supernovae. There was the Crab supernova, and there was Kepler's supernova, and Tycho's supernova, and stuff like that, right? And there was maybe a Gesar reported by Chinese astronomers in 185 AD. It's not clear if that was a supernova, but it might have been. And so we looked for radiocarbon evidence in the years of those supernovae where you saw a radiocarbon sort of tick. Didn't see anything. So those very nearby bright supernovae didn't cause a radiocarbon effect. And meanwhile, there's no written records of any interesting astronomical phenomena happening in the years of the Nyack event. So nothing is mentioned by ancient astronomers in 993 AD, 774 AD. There is a mention in the Anglo-Saxon Chronicle in 774 AD of a red crucifix in the sky, which is sort of pretty ambiguous because if you're an Anglo-Saxon monk, anything looks like a crucifix, right? All this says is they saw something in the sky, and it's really unclear how to interpret that. No one else reported anything interesting that year either. And that's it, Sage. I think it really needs more research because this is a potential threat to our civilization. I don't want to over-egg it. It's a pretty rare threat.
A lot of our listeners will still remember the Great Quebec blackout from 1989, so yeah.
Very much so. Even big solar flares today cause blackouts, let alone enormous solar flares hundreds of thousands of times bigger.
People keep saying, what's the big deal with a blackout for a couple of hours? And I tell them, well, it's not just a couple of hours. You've got to replace those transformers. You can only build transformers at a set rate. If you've wiped out the world's transformers in one blast, how are you going to replace those overnight? You're not. You're going to have to build new ones. And it's going to take years and years.
It would take years to recover.
That's Dr. Benjamin Pope from the University of Queensland. And this is SpaceTime. Still to come, yet another delay to the Artemis 1 moon mission, and 23 tons of Chinese space junk comes crashing back to Earth. All that and more coming up on SpaceTime. Hurricane Nicole has made landfall along Florida's east coast as a Category 1 storm. But the cyclone forced another delay in the planned launch of NASA's Artemis 1 moon mission. The flight aboard the world's most powerful rocket, NASA's Space Launch System, or SLS, was slated to launch on November the 14th. But Hurricane Nicole has now forced a 2-day delay in the mission. It's the latest in a series of setbacks for the Artemis program, which will eventually see humans return to the moon in 2025 and establish a permanent lunar presence there before ultimately expanding onto Mars and beyond. The unmanned Artemis 1 mission was originally slated to launch in late August, but leaks in the liquid hydrogen fuel line system on the launch pad and a faulty sensor on one of the SLS core stage engines pushed the target launch date back by a month. Then Hurricane Ian erupted on the Caribbean before ripping into Florida from the Gulf Coast to the Atlantic Ocean in late September. The impending tempest forced NASA to roll the 98-metre-tall rocket off the launch pad and back into the vehicle assembly building 6.4 kilometres away for safekeeping. The massive rocket was returned to Launch Pad 39B on November the 4th in preparations for what was expected to be a launch on November the 14th. But then came Hurricane Nicole. Nicole was nowhere near as powerful or devastating as Ian. The SLS rocket's designed to withstand heavy rains and wind gusts up to 140 kilometers per hour. Nicole was well within those structural tolerances, so the Artemis 1 remained on the launch pad. However, the Kennedy Space Center itself was placed on hurricane condition or HURCON 3 and 4 status. That means property and equipment were secured, and a special ride-out team was bunkered in place to monitor the storm as it passed. Now, if Artemis 1 does launch as now slated on the 16th, the Orion capsule will splash down in the North Pacific Ocean on December the 11th. When it does fly from the Kennedy Space Center in Florida, Artemis 1 will carry an unmanned Orion spacecraft around the moon and back again, testing the new launch system for the first time. And NASA says if Artemis 1 misses its November 16 launch window, the next launch opportunity will come on November the 19th. We'll keep you informed. This is SpaceTime. Still to come, a spectacular full lunar eclipse, 23 tons of Chinese space junk comes crashing back to Earth, and later in the science report, new data confirms that the past 8 years were the hottest on record. All that and more still to come on SpaceTime. Well, in case you missed it, earthlings over much of the planet have been treated to a spectacular celestial display with a total lunar eclipse, turning the full moon a deep red. Lunar eclipses happen because the orbits of the Earth and Moon are both slightly tilted and elongated in relation to each other. So, occasionally, instead of passing just above or just below the Sun as usually happens, the new moon appears to pass directly in front of the Sun, causing a solar eclipse. And the lunar eclipse happens either 2 weeks before or after a solar eclipse during the full moon phase, as the Earth's shadow passes directly over the moon, blocking out sunlight. But sunlight still reaches the moon, refracted through the Earth's atmosphere, and thus bathing the moon in a pinkish burgundy hue, displaying all the world's sunsets and sunrises at once. Dust and vapour in the Earth's atmosphere further changes the colour, making it seem more pinkish or reddish. Last week's event was visible right across Australia, as well as North and Central America, most of South America, all over the Pacific Ocean, as well as New Zealand, and even into Asia. It was the last chance to glimpse a total lunar eclipse until 2025. 23 tons of Chinese space junk has crashed back to Earth, splashing down in the South Central Pacific Ocean. The uncontrolled descent followed the launch of a Long March 5B rocket from the Wenchang Satellite Launch Center on Henan Island in the South China Sea, carrying the final module of China's new Tiangong or Heavenly Palace space station. The Long March 5B's YF-77 liquid-fueled engines can't restart once they're shut down in orbit, and so mission managers simply allow the disused rocket to plummet back to Earth in a dangerous uncontrolled re-entry. Other spacefaring nations guide their disused spacecraft towards a designated satellite graveyard position known as Point Nemo, an isolated region of the southeastern Pacific Ocean, far from any landmass or trade routes. Because of the uncontrolled nature of the Chinese deorbit and re-entry, people on the ground can't be warned in advance of impending danger. The violently spinning rocket body's orbit gradually decays as it encounters more and more of the Earth's atmosphere. The orbital decay comes from a reduction in speed due to atmospheric drag. However, the rate of orbital decay depends on the ever-changing density of the atmosphere, and that depends on the strength of the solar wind. All these variables mean the exact point of atmospheric re-entry can't be determined until, well, literally it happens. The spent rocket body simply bounces and surfs along the upper layers of the atmosphere, dropping deeper with each orbit until the final death plunge begins. And scientists can't be sure of when that happens until it happens. Scientists did issue a warning when they determined the rocket body could have been on its last orbit. Spain even closed part of its airspace in the skies above Barcelona for almost an hour as the Chinese space junk remnants flew overhead. The region of greatest concern was a wide area of the planet from North and Central America to large parts of Africa and even southeastern Australia. The United States Space Command finally confirmed the rocket re-entered Earth's atmosphere at 4:01 a.m., splashing down in the South Central Pacific Ocean. The problem is China's become a regular offender of these dangerous types of uncontrolled deorbits. In July, a spent Long March 5B crashed into the Indian Ocean in the Sulu Sea between the Philippines and Borneo in another uncontrolled deorbit. And of course, another Long March 5B fell into the Indian Ocean off the coast of the Maldives in April 2021 in another uncontrolled deorbit and re-entry. That was seen by numerous witnesses, including members of the Australian cricket team. And in 2020, huge chunks of Long March 5B crashed back to Earth in the Ivory Coast, damaging a number of buildings in several villages. And it was pure luck that no one was injured. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. A new report by the World Meteorological Organization has found that the past 8 years are on track to be the warmest 8 years on record. The 2022 Global Climate Report also found that the rate at which sea levels are increasing has doubled since 1993. Worse still, The study shows it's risen nearly 10 millimetres since January 2020 to a new record high this year. In fact, the past 2.5 years alone account for 10% of the overall rise in sea levels since satellite measurements started some 30 years ago. A rare triple-dip cooling La Niña means 2022 is likely to only be the 5th or 6th warmest year ever. However, this isn't reversing the overall long-term trend, and the report states that it's only a matter of time until the Earth faces yet another warmest year on record. New studies have confirmed that schools in the United States which removed the requirement to wear masks wound up having higher COVID-19 transmission rates than schools which maintained a mask mandate. The report in the New England Journal of Medicine shows that the state of Massachusetts dropped a requirement for schools to wear masks in February 2022. But not all school districts responded by removing masks, providing an opportunity for scientists to compare COVID-19 transmission between masked and non-masked schools. The authors say that while transmission trends were similar across school districts before the change, 44.9% more cases per 1,000 students were reported among schools that dropped the mask requirements in the first 15 weeks, compared to those which mandated masks. More than 6.6 million people have now been killed by the COVID-19 coronavirus since it was first detected near China's Wuhan Institute of Virology around September 2019. However, the World Health Organization says the true death toll from COVID-19 is now likely to be over 15 million, with some 640 million confirmed cases globally. While the Lancet Commission, a panel of world-leading experts in policy and disease management, estimates the COVID-19 death toll could be as high as 18 million people. Scientists have found that a type of immune cell called a memory B cell becomes less effective with age. The study in the journal Cell Reports may explain why flu vaccines work less well among senior citizens compared to younger people. The authors tracked B cells in 20 healthy people after they were given a trivalent flu jab. Younger people developed an atypical type of B cell in response, and these cells derived from a particular type of cell precursor known as a germinal center precursor. However, the process was seen to happen far less frequently in elderly people. The studies suggest that the activity of both germinal precursors and memory B cells decreases with age, which may explain why flu jabs don't work as well among older people. People around Manchester and north of England have been treated to a bit of a chuckle with a local Fairfield Street billboard displaying a message which simply reads, "Psychic wanted. You know where to apply." Tim Mendham from Australian Skeptics says a man simply walked into the company's advertising office and ordered and paid for the sign, saying a true medium will know how to contact him.
This is a billboard. It was hardly exactly full of lots of information. It basically just said in very large font, "Psychic wanted, you know where to apply." So had no contact details, no phone number, no website, nothing at all. It's just saying that if you're a psychic, you know who to contact to reach this person. Now, the company that looks after the billboards and puts the signs up did not reveal who actually put it up. They're saying they thought it might have been a joke, but then they thought, this person might have been seriously after a genuine psychic, if there is such a thing. But I also suspect that it might have been skeptics who put it up. Yes.
Cheap.
No, but they don't cost. It doesn't know how long. Honestly, I don't know how long it was up, but it got a hell of a lot of publicity around the world. So if it cost them, say, a couple of $1,000s, which it could do, I mean, they've got to print this thing, which is what the company does for you. You print this thing, stick it up, glue it up, and then take it down after a week. But it's not necessarily hugely expensive, a few thousand perhaps. And if you can afford that and you got publicity around the world, you might consider that worthwhile. It's a jokey message.
Yeah.
How serious is the message? It has serious implications that we all know. If psychics could do this, why couldn't they just contact me? Why do they need all the information first?
Well, why do they even need to be told about it? They should know that automatically.
Why do they need to put a billboard up?
Exactly.
Right. Oh, dear. I know. It was a publicity stunt. That's why I tend to think it's actually, it's obviously a skeptics group. I can't confirm that. There are skeptics groups in Manchester and that part of the UK who are very active with a sense of humour. I know them. So whether it was theirs or whether it was someone individually making a message or someone genuinely wanting to find a genuine psychic. But the way they did it implies to me it's a message billboard rather than a serious advertising attempt. Anyway, it's a lot of fun.
That's Tim Mendham from Australian Skeptics. that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.